Welcome to our functions and one-to-one review. Sorry I couldn't be there with you guys, but this is the next best thing. Me teaching you through the internet. So let's start with the first one. Remember, when you want to graph a function needs to pass what's called the vertical line test. Okay, so if you draw any vertical line you draw, can only intersect the graph at only one. Okay, it can only cross at one point. So if we look at the first example here, we want to draw ourselves a line, and as long as we draw any line we want, it should only cross at one point. We talked about this one the other day. So this one would not be a function because it's intersecting at 2 points. Here you can see this one is only going to hit at 1, and same thing here, no matter where we put that line, it's only going to hit at 1. Okay, so which does not represent a function would be choice apparently 3 here for that graph is the one we're looking for. All right, which graph does represent a function again? All right, here we can see like that's going to hit twice. So even though like I can draw this line out here that only touches once, as long as I can draw a single line that hits more than once, this will not be a function. Okay, so this is not a function. Also, this one isn't because that line overlaps the whole thing. So this one would be the one that is a function. So we would say that this is our function. Okay. The question the other day was why, why do we care about functions? And the answer to that one, for you, Lucas, I know you asked that question, was that there are certain things we get to math, like derivatives, inverses, and things that we want to get to in higher level math, and we need to know that these are functions in order for these to be true, in order for us to be able to interact with these relations in that way. You can't do an integral or a derivative or anything in calculus if you don't have a function, because I need to know that if I'm evaluating at let's say when x is equal to 2, then I'm going to get a single result, and I'm not going to get like two different answers. So that's why we need to know that if I look at this x value, I'm only going to get one result instead of two possible ones. So that's why we need to know that it's a function. A one-to-one function, okay, has no repeated y values. All right, so this one is actually going to be using a horizontal line test for. So now, if I want to check, first of all, is it a function? So if I'm looking for a one-to-one, first question I'm going to ask is it a function? And so this one is yes, it's a function, and we can tell because we can check our vertical line test here and see that, right, this is only going to get hit once. And then once we know it's a function, we can do a horizontal line test and check to see if it's one-to-one. So the answer is yes. Is it one-to-one? Yes, it passes the vertical line test. Our domain, so remember we're going to do the domain, and here we can see that no matter what x value we choose, we'll always have the graph. We'll always have a y value for that x value. So the domain is the set of x, right? Such that, let's see if we can get a such that bar here. Such that bar. We'll make our own. Such that. All right. And we're going to have that x, right, equals all real numbers. All right. And our range is going to be the same thing here. Okay. So the range, and the difference here is we're going to change these to y's instead of x's. All right. So let's see if you guys can go through and do number 4. So actually, we'll do this one together, number 4, right? So is it a function? And we can say, no, it's not a function. Since it's not a function, we're not even going to consider the one-to-one. It has to be a function in order for it to be one-to-one. So we're just going to put NA here because it's not applicable to our question. We can still figure out the domain of this relation. The domain would be the x values, right, such that x is actually in between two numbers, right? So it's -3, and we want to go with is less than or equal to x, which is less than or equal to 3. All right, and our range is actually the same thing, except it's y's instead of x's. So it's the set of y such that y is also stuck between, right, -3 and +3 here. And this is a really good way to actually look at domain and range, is actually to use your calculator and check out the graph. All right, so let's take a look at the next one. So can we do the vertical line test? Is it going to always hit at only one spot? And the answer is yes. So is it a function? And we would say yes. And so we're going to check onto. So we're going to grab and do a horizontal line test. You can see like, oh, only hits once. But, oh, hits more than once at that point, right? There's a whole bunch there. So it is not one-to-one. And now we can do the domain. Okay, so let me just get rid of these so we can see it better. So for the domain, you can see that it's always going to move forever and ever and ever going down. So as we get further and further negative, we're still going to have y values, and the same thing for the x. So the domain is, right, the domain, the set of x such that x, right, is equal to all real numbers. Or if you want to use that awesome, I don't have that, but we can do it, right? So let's do it for this one. Right, equals our awesome all real number symbol. So, all right. And the range is not going to be all real numbers this time. So we can see it's always going to go down, and it's going to, like, the y values are going to continue to go down forever. But when it gets to this value, it's going to continue to move straight to the right. So it's never actually going to get above 1, 2, 3, 4, 5 on the y-axis. So my range, okay, is going to be the set of y such that, right? And we're going to say y has to be, and we want to be below, so we're going to go less than or equal to, and we know that number is 5. All right, and then we're going to fill in our little such that line, and we're good to go. Okay, so you guys try 6. And then the nature of the graph is another thing we're going to continue on. So the nature of graph is just as you move from left to right, okay, as you move from left to right, is the graph tending to increase or is it decreasing? So the nature of the graph is just, the answer is going to be it's increasing or it's decreasing. Remember, the intercepts are where the graph crosses the x and y axes. All right, so graph the line that contains the following points. So we got -6, 5, 2, 3, 4, 5, 6. 1, 2, 3. So we got that point right here. We got -4, 4, -2, 3, 0, 2, and you can see we're going to get this line right here. All right. And so we're going to go in and we're going to fill this information in for ourselves. So, all right, so is it a function, right? We say yes, passes the vertical line test. Is it one-to-one? Remember, does it pass the horizontal line test? Yes, it does. The nature of the graph, so as we move from left to right, so in this direction, going from left to right, we can see that the graph is decreasing. And the x and y intercepts, right? The x-intercept as we continue to move down here, okay? You can see the next point's here, and the following point is going to be over there. So if we continue this out, all right, we can see where that hits. So the x-intercept, all right, is going to be at 4, and y-intercept is at 2. Okay, it's not the point, it's just the value on the x and y axis where this line is going to cross. All right, you're going to do the same thing to this guy, so go ahead and graph that for yourself. All right, we're going to take a look at number 9 together, so you can see we're just following all these lovely points. So we want to know what's the domain of the function and what's the range. So the domain, right, is the x values. So we're starting with a dot at 0. We go all the way to here and we're stopping, and that number is at 12. The domain is the set of x such that x, right, we said actually we want to give a compound inequality. So we're going to say x has to be and apparently I broke something. X has to be, there we go, in between 0 and 5. So it's got to be greater than 0. So when I say 0 is less than x, and also at the same time, x is less than 12. All right. So that's going to finish up that one. Cross that line in. And then the range, let's see if you guys can do the range on your own here, right? So what are the y values that we're sticking in between here? All right. Same thing with these guys. And then you got a range on the bottom here as well. And then let's see if you guys can finish up this for homework tonight, okay? So finish these guys for homework. That's it for today, guys. And I will see you tomorrow.